Right, question 3 for year 13. So, circle C has centre P, which is 7, 8, marked on the diagram, and passes through the point Q, which is 10, 13. As shown in figure 2, find the length PQ given your answer as an exact value. So, find the length of PQ, and we want it as an exact value. Now, remember to figure out, so effectively what we want here is that distance between P and Q there. Okay? So, to figure out that distance, we're going to imagine that this is a right angle triangle, and we're going to use Pythagoras theory. So we're going to use the distance in terms of the x coordinates, which is between 7 and 10, and then use the distance between the y coordinates, which is 8 and 13. Okay, so if we've got 7, 8 and 10, 13, distance between the x's is 3, distance between the y's is 5, so the distance altogether will be root 3 squared plus 5 squared. Just do that on my calculator. Square root of 3 squared plus 5 squared, which gives me root 34. Right, part B. Hence write down an equation for C. Remember that your equation for the circle C will look like this. So we'll have x minus the x coordinate for the centre all squared plus y minus the y coordinate for centre all squared equals the radius squared. Now I've just figured out that the radius is root 34. So I've got everything I need up there basically. This and this. So my answer is going to be x minus 7 all squared plus y minus 8 all squared equals root 34 all squared. Which, you know, we can sort of tidy that up. X minus 7 all squared plus y minus 8 all squared equals 34. I'm done. Right? Right, the line L is a tangent to C, so it's a tangent to the circle at the point Q. Find an equation for L, given your answer in the form ax plus by equals c, where we've got integers. So, quite a lot of steps for this. Usually with something like this, if we're figuring out a tangent, we'd want to differentiate, but we can't differentiate circles. What we use is the fact that that is a radius and that is a tangent, so they will be at right angles. So what I'm going to do is I'm going to figure out the gradient of the radius. I'm then going to turn it into the negative reciprocal to get the gradient of this line, this tangent, which will be perpendicular to the gradient. And then I know I've got a coordinate, which is 10, 13, to use with y minus y1 equals mx minus x1. So I'm going to write down each step. So figuring out the gradient m for the radius. But between there and there, the change in y, I've gone from 8 to 13, so that's 5. Over the change in x, we've gone from 7 to 10, so that's 3. So that's plus 5 over 3. So the gradient for the tangent is going to be minus 3 over 5, the negative reciprocal. And then I can use the point Q, which is 10, 13, because I know that the tangent goes through 10, 13. So I can plug all that into y minus y1 equals mx minus x1. So I've got y minus 13 equals minus 3 over 5 brackets x minus 10. Now when I get something like that, because I've got a fractional gradient, I'm going to multiply this side by first and then times the bracket out using minus 3. So positive 5 times them, minus 3 times that. So that's going to give me 5y minus 65 equals minus 3x plus 30. So I've got loads of integers there. Just need to make it equal 0. Because I've got a negative x term there, I'm going to bring everything onto the left-hand side. So I'm going to get 3x plus 5y minus 65 minus another 30, it's going to go over there, minus 95 equals 0.